So for this question, it's a Pearson's product moment correlation to start with, so a linear correlation line. And you're asked to find the value of that correlation. So to do that, we need to, first of all, add our data into our calculator. So we're going to edit the data, and list 1 is going to be your mass, your X, and then the BMD is going to be your list 2 or Y. So we have our data input, and now we're going to go to statistics, calculations, and we're looking for that linear regression. So we get our R value, which is 0.604. So for part A of the question here, the R value is 0.604. Now, if you couldn't, or 5, sorry, to 3 significant figures, if you didn't get your R value up, then that's because you haven't got it activated. So you go to second function, catalog, and you scroll down to diagnostics, and you need to turn your diagnostics on. So if you don't get that up, you need to turn your diagnostics on and then redo it. So the next part is to interpret that relationship. So that's a medium, sort of relatively strong correlation, and it's a positive correlation. So moderate positive correlation. And then for part B, find the least squares regression line. So this one is just asking for the regression line. It's the only regression line we do. If you see that, it just means regression line. So we already have this on our screen. So you can write this as y equals ax plus b, where a is equal to 0.0319 to 3 significant figures, and b is equal to minus 2.44 to 3 significant figures. You can write it like this, or you can write it out in full, where you're just placing those values into your equation. Either of these is fine, but you do not get the marks just for writing this. You have to write this with it. So part C is then to use the regression line to estimate something with a mass of 92. So the mass is the X, so I'm now substituting in X is 92. So Y is equal to 0.0319 times 92 minus 2.44. And that gives me an answer on my calculator of 0.497. And we need to discuss the reliability. So a value of 92 has gone in. We do have values around 92. Our highest value is 104 and our smallest value is 57. So it's within the range of the data, which is good. However, because the correlation value isn't as strong as it could be, there is still a margin of error, but you could argue it either way, so long as you give your reasons. For part D, you're copying and completing the table for your ranks. So it's up to you whether you start on the biggest or the smallest value. But on this one, they have given you the first one here, which is F is 1. So that suggests that they're starting on the smallest value, and then we work up. So if we start filling this in, so H would be the next biggest, C would be the next biggest, and so on. And then we're going to do the same again for the second piece of data. So the first three are filled in for us, and then we have the fourth biggest, fifth biggest, sixth biggest. Now the 7 and the 8th, these two G and H, are exactly the same. Okay, so that means that they split the 7th and 8th term, and they both become 7.5. So these are both 7.5. And now we've used the 8th, so we jump straight to the 9th and then the 10th value. So we now need to use our ranked data in order to find my Spearman rank correlation coefficient. So to do this, I'm going to go back to my calculator, and this time I'm going to type back in my list but with ranks. So this is my ranked data, and I'm now going to do the same as before. So my R value this time for Spearman's rank is 0.620. So in terms of describing what that means, it's a very similar correlation value to what we had previously, but it is slightly stronger. And therefore it suggests that it might be a non-linear relationship if the non-linear one is stronger.